All right, so now problem 16b, final exam practice. We want to find the area enclosed by one of the loops of this four-petaled flower that we just graphed in part A. And so, for example, we can just take this petal. It doesn't matter which one we use. They're all symmetric, so they all have the same area. But either way, we'll take this one. So this will be bounded between the values of theta 0 and theta equals pi over 2. All right, so we need to write down our area formula. So this will be from theta equals 0 to theta equals pi over 2. And we just need to write down our integrand, which is 1/2 r squared d theta. Okay, so we know that well, actually, I already had that theta was between 0 and pi over 2, so either way, that's the reason why theta is between 0 and pi over 2. So either way, we have r is equal to sine 2 theta, so I'll just substitute that expression for r. I'll pull the 1/2 out front because it's a common multiple, integrating from 0 to pi over 2. I have sine squared of 2 theta, d theta. And so I know every time I see an expression like sine squared of anything, I'm going to reduce this power of sine using my half angle formula. So this will turn into, so I have a 1/2, integrate from 0 to pi over 2. This is going to be 1/2 1 minus cosine of 2 times the argument, so that's 4 theta at this point, d theta. Okay, so one way to think about this next step is that I see that I have a cosine of 4 theta. The period of cosine is 2 pi. So as theta goes between 0 and pi over 2, cosine runs between the values 0 and 2 pi. And so this is an integration of cosine over a full cycle, so it'll actually just cancel out. So I can just go ahead and get rid of that. But the other way to see it is, and I'll write the step here to actually show the integration and why it equals 0. But that's one way to reason through it, is with this cycle business. So we integrated over one full cycle. So we saw all even values and all negative values equally, and so those areas canceled out. So either way, we're integrating 1/2 with respect to theta, so we're just going to get 1/2 theta. And then we want to evaluate at pi over 2 and at 0. Oh, and I don't want to forget about the rest of this stuff, so we would have 1/2 times 1/2. So this would be n minus 1/4. And then cosine of 4 theta, the antiderivative of that, would just be equal to 1 over 4 sine of 4 theta. Again, check that this has derivative cosine of 4 theta. So either way, we evaluate at pi over 2 and at 0. So I'll take care of this term. I'll show it's equal to 0. So clearly, when theta is equal to 0, sine of 4 times 0 is sine of 0. That's just equal to 0. So this term contributes nothing. When theta equals pi over 2, 4 times pi over 2 is 2 pi. So sine of 2 pi is just equal to sine of 0. This is 0. So this term contributes actually nothing. And this is essentially why we were able to cross out the cosine 4 theta from the beginning. So either way, what we're left with is 1/4 times theta. So theta is pi over 2. Pi over 2. And then evaluating at 0, of course, I get 0. And so this is ultimately equal to pi over 8. All right, so that's the area of one of these leaves of our beautiful four-petaled flower.